Okay, sorry about that. So the fourth part of the particle model is that particles in matter are always in motion, which we looked at already as well. So here we have different particles are always in motion, okay? But usually the temperature is related to how much motion there is. So the higher the temperature is, the more movement those particles have. So particles are always moving. I'm just going to use little arrows to represent movement. So here we have cold particles versus hot particles. So I'm just going to use larger arrows to represent more movement. So the warmer the particles are, it's related to how much energy they have. Typically, the higher the temperature, the more movement those particles have. But in general, particles are always moving. The more they're moving is directly related to the temperature that they are. And the fifth one is that particles are attracted to one another. Now, the amount of attraction they have has to do with the amount of space between particles. So if the particles are close to each other, that tells us that there is a strong attraction between the particles. So for example, solids that have very condensed particles have a high attraction for each other. So when we're doing this and we're looking at the state of matter, we can have an understanding that because these have strong attractions for each other, they're going to be tightly compact, right? The further away the particles are from each other, the weaker the attraction is. So the direct opposite of solids in terms of attraction is going to be gases, right? So gases have a weak attraction between particles, which is part of why they're so far apart from one another. So those are the 5 statements for the particle theory. Okay, so now let's look at how does this relate to the states of matter. So this is going to be repetitive because we've mentioned a lot of these already. So solids have a definite shape and volume, and they can be compressed but only slightly. Now this is dependent on what type of solid we're dealing with here, okay? So for example, if it's Play-Doh, right, it's more compressible than if you had like a piece of iron or something, a piece of metal. So this is very generalized. Normally, they're very difficult to compress. Okay, so why is that? They have strong attractive forces between particles, which is what we just mentioned, right? They're close together. There's not a lot of space between them. Liquids flow easily. They do not have a definite shape. So remember, the term definite means like constant. So the shape is able to change, but the volume is definite. So if I have different sizes of containers that my liquid is in, it's still the same amount of liquid. It's just changing the shape of that liquid. So the reason why it's able to flow and change shape is because there's weaker attractive forces in comparison to solids. So meaning there's more space between particles. The particles are moving more. So they're able to move and shift around one another much easier. Gases do not have a definite shape or definite volume. They basically will take on whatever shape of the container is that they're in. And they can be compressed. So the reason why they're able to be compressed is because the particles have large amounts of space between them. Okay, so why do they have such large amount of space between them? It's because the forces of attraction are very weak. The particles are far apart and they're moving relatively fast because these particles have more energy than they do in liquids and solids.